All right, last installment, cross sections, semicircles. Okay, so if we have the volume and it's perpendicular to the x, my cross section's base is perpendicular to the x-axis. That means, well, perpendicular to the x-axis is going to be vertical. And a vertical distance, you know, you do top minus bottom. Imagine you have a semicircle. Okay, so the diameter is what's in the picture spanning from the functions. So you know that volume is the integral of area and you know the area formula for a semicircle, well, for regular circle it's pi squared, but you divide that by 2. And this vertical distance right here is d. And d is known as the diameter. So you know that the radius is half the diameter. So the diameter in this case is going to be top minus bottom, which in this case, if I were to label these two functions, let's call the red one f and the blue one g, then it would be f of x minus g of x. Okay, is equal to d. But since the radius divided by, not the radius, the diameter over 2 is equal to the radius, then that means that my radius is equal to f minus g over 2. Okay, or top minus bottom over 2. So I'm going to write that two ways. So I have top minus bottom over 2 squared dx, and that's just the r squared, right? Then you have this pi over 2 in the front. So we have pi over 2. And then we talked about how you could square this 2 on the bottom, which makes a 4, multiply with this 2 on the bottom, which makes 8, and it's pi over 8, the integral of top minus bottom squared dx. Okay, or you could say f minus g, whatever. Then I'll write it out. f of x minus g of x squared dx. Now if my volume of my cross section is perpendicular to the y-axis, it's literally the same thing. It's just from y sub 1 to y sub 2, a of y dy, where my area formula is my semicircle. So then if I were to erase this over here, sketch this back in, whatever, that's a little hurt. It's fine. Then perpendicular to the y-axis is going to be horizontal, right? And this time my semicircle looks like this, where the circular part is popping off of the page. And this horizontal distance, well, this is d, my diameter. And you know, when you do horizontal distance, it's right minus left. So in this case, my right function is the blue function, so it's going to be g of y minus f of y. Because remember, everything has to be with respect to y if I'm doing perpendicular to the y-axis. So there's the pi over 2 from this area formula for a semicircle, and then I integrate, and you know the radius is going to be half the diameter. So this radius is going to be g of y minus f of y over 2, or right minus left over 2. So first I'll write with right minus left, so it's going to be right minus left over 2 squared dy. All right, and remember I can square this 2 on the bottom, which makes a 4, because that square there multiply with this 2, and that would just be pi over 8, right minus left squared dy. Now if I want to put the functions f and g in here, according to my example, the way I wrote it, it would be pi over 8 integral y sub 1 to y sub 2. It would be g of y minus f of y squared dy. That's it.